Welcome to some quick pointers on quickly establishing the relationships between variables, being able to work this stuff out just by looking at the equations. So we have some sample questions here that match up with the mile marker. The first one has to do with judging whether our relationship between KE and V in our equation, is it direct or inverse, linear, or something else? So if we're talking about our direct versus inverse in the equation, if we have one variable already alone, we have to do that. So when we get one variable alone, where is the other? Is it in the numerator or is it in the denominator? So if it's in the numerator, then it's going to be a direct relationship. If it's in the denominator, that's indicating an inverse relationship. Now, we go into more detail than that. We have direct linear, direct quadratic, inverse squared. So, okay, first we'll establish direct versus inverse. Here, because both variables are in the numerator, we have a direct relationship. Is it direct linear or direct quadratic? Well, the second part we can work out using, not the math class terms, but I just call it plain versus fancy. So if you have an equation like net force equals ma, where both force and a, not only are they in the numerator, but acceleration and net force are both plain when we solve for one, then they're a linear relationship. Fancy, what is fancy? Anything that isn't plain. So for example, having v squared, that's not linear. In fact, v squared would be getting us a direct quadratic. All right, so direct versus inverse, linear versus nonlinear. We can find those just by looking at the equation. Next up, we can look at whether how to determine proportions, where if we make changes to variables, what will happen to the other variables in the equation. And what we're being asked here is, what is the change, not what's the new value, but what is the change, how much would it be changed? So in this problem, it's saying if we multiply Q by 2 times, and if we multiply D by 3 times. And so the easiest way to keep track of this is to write your equation with blanks in front of the variables. Notice I didn't put a blank in front of the K because K is a constant. Only the variables changed. Similarly, on our previous page, where it had kinetic energy was 1/2 mv squared, I could put a blank in front of the m, I could put a blank in front of the v. I don't put a blank in front of the 1/2. 1/2 is constant, and it's not going to contribute to our changes. Okay, so in this question here then, it said Q is multiplied by 2, and D is multiplied by 3 times its original. And we need to follow the guidance of the equation here. That includes any thing that isn't just a straight up linear function. We have to do what the equation says. So it's saying that we would square the distance. So that means we're also going to square this 3. We have 2 over 3 squared. And if I do that, and I put that in my calculator, I'm going to get 0.2222. And so this is telling me that my new electric field strength, compared with the old, my new value for E, in other words, is 0.222 times our old value. So it is changed by that much. So that allows me to select that. So again, this isn't the new value, this is how much it has changed. If it was 1, it means we haven't changed at all. Any number greater than 1 means we've increased. And any number smaller than 1, like 0.22, if I multiply by 0.22, we're going to get a smaller number. This is, in fact, saying 22% of the old value, so decreased. Okay, in the last and the most involved of the problems that we have, we're doing pretty much this same thing, except we're actually generating the new value. So I'm going to again copy my equation, and I'm going to again figure out how much the value is changed. So everything we just did on the previous problem, and we'll just have one final step after that. So let's look at that. It says M1 is changed to 0.2 times its original. M2 is changed to doubled. It has been doubled. And that R is changed to 0.25. So my new value is going to be 0.2 times 2 divided by 0.25 squared. The change that's happening, I'm going to plug into my calculator. So when I do that, 0.2 times 2 divided by 0.25 squared, that's going to tell me that the changed value is going to be 6.4 times bigger than the old force of gravity. But notice here, there's nothing that says 6.4, nothing about multiplying. Because they gave us the old value. They said the old value started out at 20 newtons. So we are doing 6.4 times that old value, 20 newtons. And when I put that in my calculator, then I get 128 newtons, which it is closest to our 130 newtons in our example. All right, I hope these quick pointers help you work through this method, and we can use this method in so many situations, so it's worth the practice. Good luck, and thanks for watching.